let's get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
Are an open culture that
it's actually a big piece
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed.
Hello, good morning, good afternoon, good evening, wherever you are in the world. This is the Ask an OpenShift Expert live stream. This week, we are going to do part 2 of our migrating your VMware workloads to OpenShift series. It's Jonathan who will join us shortly. He reached out and said, "Hey, I've got a couple of topics that I'd love to see on the live stream." And so, we're very able to welcome Jonathan, and we're very lucky to make it happen. And yeah, it's so far OpenShift virtualization and AI, obviously AI, have been such hot topics within Red Hat and then our community in general. So it's cool that we're able to get to these topics and really dive in on some of the things that are important to our viewers and everybody around us within Red Hat and our community as well. Something that I've failed to mention in the last few live streams is the reason why we're here, right? So the Ask an OpenShift Expert live stream is part of the Red Hat Red Hat Office Hours series of live streams, which really, at the end of the day, it's for people like Sully and I to get to nerd out with very smart people like Atta, John, and Anupam, and answer questions and take your questions and give you a place as a viewer or a listener to come and ask questions regardless of how trivial you think they are, and you get to ask a question in a safe place where we'll answer it for you, because we really want to talk to you. We want to know what you're doing. We want to know what issues that you're running into, and we learn from you and you learn from us. So it's a reciprocating relationship. So if you have questions and you don't feel comfortable asking, you're always welcome to email me. I'm Jonny, Jonny at redhat.com, and Sully is Sully at redhat.com. And we love getting the messages from you. We'll do our best to answer them. I can tell you from experience that Sully is in email jail right now. Like he is working and earning his paycheck, tenfold right now. So hopefully we'll get him back in the next couple episodes. As far as the upcoming topics, we don't have anything booked just yet for next week, but we do. I think the next guest that we have is on the 29th, and this Peter Kreuzer and his team are coming back, and they're going to do some user experience things with ACS. So ACS is getting a ton of upgrades. There's a lot of magic starting to happen. The VM support is really awesome. And they're going to come on and they're going to show how they're making that experience within the console way, way better for you, the consumer of the product. Since we don't have a topic defined next week, we'll probably come up with something. We'll go back in the catalog and see if there's something that we should redo. We did the disconnected, and if you're eagle-eyed and you realize that I haven't updated the disconnected description yet, that's because I'm terrible at doing my job, and I need to go back and update with the README and all the things that you need. All right. So with that said, last week we did OpenShift virtualization. It was part 1 of migrating VMware workloads into OpenShift virtualization. Jared had talked about this landing page that was on the Red Hat website, and I just wanted to make sure that we shared it. And yeah, so if you go to this website, it's the OpenShift Virtualization Learning Hub. Jonathan actually sent me the link, so I'm sharing it now and making sure that you have it. This is a great resource for trying to figure out how to get started with OpenShift virtualization and really identifying where the resources that you can use or that are available to you are. So take advantage of this. If you have any questions, let me know. And with that, Jonathan, thank you for coming back, man. I really do appreciate you doing this. How about you do a quick intro?
Sure. Thank you for having me. The topic today is part 2 of virtualization, and we have some experts who will show us how they use actually machine learning to plan out the migration from an alternate from your current virtualization estate over to OpenShift Virt. So let's just do a quick slide intro for 2 minutes for a refresher, or for anyone who wasn't on last week.
Yep, and Jonathan, before you do that, let's do quick intros real quick, so that way we know who our
yeah. So I'm Jonathan Gertz-Butter. I'm a Red Hat 12, whatever, not a whole bunch of years. You see the hair's gone, and I cover product marketing for OpenShift. And Atta, go ahead.
Yep, Atta Mufti. I'm part of the OpenShift virtualization team.
Oh, you're muted, Anupam.
Yep.
Got him.
Inevitably, right? Hi, everyone. Anupam Sengupta. I'm a principal transformation architect with Red Hat Strategic Consulting Services. I am deeply involved in the AI space. That's why some of the ML flavors will start showing through. I also am very deeply engaged across the portfolio, whether it's OpenShift, OpenShift AI, automation, and of course, visualization, the topic for today. Jan, over to you.
I'm Jan. I'm a senior architect, been with Red Hat 7.5 years, focus on OpenShift virtualization, and conducting virtual assessments and helping clients walk through their change and virtualization journey.
Awesome. Well, welcome to the live stream, guys. I really do. It's never easy doing these things, so I really appreciate you taking the time and putting yourselves out there to talk about this stuff. So thank you very much. All right, so Jonathan, let's kick it back over to you for the slides.
All right. Okay, slides are good?
Yes, sir.
Okay, so what is OpenShift virtualization? Quick refresher, there's a difference between a container and a VM. The VM has that hypervisor layer, a container does not. So it's a slimmer, smaller, faster form factor. Okay, but you can put a VM into a container and you still use compute network and storage, but containers encapsulate that process. Everything runs OpenShift virtualization, therefore runs containers and manages pods. We use the KVM hypervisor, and we have persistent storage and SDN-like networking. Just what you have for containers, you have that for VMs. So again, it uses that KVM hypervisor, and you get that benefit of sharing resources across both VMs and containers. Okay, you can use your VMs and containers together, so you have one interface, one tool set. You can use GitOps to manage both containers and VMs. You can be a ClickOps GUI and do that as well. You can enable standard Kubernetes methods such as service route, ingress, service mesh pipelines, etc., to VMs and to containers. So you have one uniform landing. Okay, so you can start and migrate slowly to what we have called OpenShift Virtualization Engine, which just allows you to run VMs, or you can thereafter up-level to OpenShift, the full application stack, and do applications and containers, and later even go onto OpenShift AI and enable AI. You do that all on the same platform. It's literally just turning a switch to enable the extra features. So you can bring those traditional VMs into OpenShift. What we're featuring today are Jupyter notebooks. Okay, that is, it's a machine learning paradigm for doing interactive data science, machine learning. It takes text visualizations and formulas into a single document. You can use it to do interactive data science. You can do data visualization, and you can do modeling. And today, the experts will show us how to use Jupyter notebooks to map your VMware environment to OpenShift Virt. And that is the intro. Thank you.
Awesome. Thank you very much. All right,
We go.
Ata.
Yeah. So just before John and Anupam show us their wizardry with Jupyter notebooks, Ata is going to discuss blast radius briefly. Thank you.
Yep. Thank you, guys. Let me go ahead and share my screen. Okay, let me put in the slideshow.
Yep, looks good.
Yep. Good morning, good afternoon, good evening, team. Thank you for joining. So today I'm going to talk about the real-world validation of the blast radius. So as we know that now hardware has evolved, and we can put up to 8 terabyte memory, even more in a 2-socket server, and the core count is really high these days. I mean, some AMD and Intel, they are really pushing for higher core count servers, maybe over 300. I've seen 392 cores. So Some of our customers, they come to us and ask about the node sizing. Will they go for larger node size or smaller node size? Of course, larger node size increase your blast radius. You have more workload running, and in case of an outage, you have more applications that are down. So what we did in our lab, we basically done that testing. Here is my agenda. So today I'm going to talk about why blast radius matter and how we did the real world lab validation and prove those results. And now we have advice for the customer if they should go for larger node size and scale them, or they should stick with the smaller node size to stay with the lower impact or lower blast radius. Oh, sorry, next slide. So what we are going to deliver the message is that the blast radius is determined by the recovery capability, not the node size alone. So if node size are scaled proportionally or properly, you can essentially have a better impact or lower your recovery window. So why blast radius? As we know, if we have a larger node, we have more workload running on it. And in case of an outage, it is going to increase our outage window or recovery capability. So and then we went ahead and did a real world test, tried to simulate this thing in our lab by simulating a larger nodes and a smaller nodes, put workload and containers, VMs and containers side by side, scale those nodes properly and validate our testing. So our test environment. So basically what we did in our lab, we created two clusters. One was small cluster, we call it small cluster, and the other one was a large cluster. As we see on the screen, both clusters has 3 nodes. The smaller cluster has total of 64 cores, 2 socket server, 32 core each. My larger cluster, it has single socket but 120 core on each socket. It means the core count was doubled on the larger cluster. Same goes for memory, double the memory. When we did the workloads, we had double the workload on the larger cluster compared to small cluster. So small cluster were running 60 VM, 30 containers, where the larger cluster had 120 VMs and 60 containers. All the VM sizes were identical. For the network, we scale the network so the larger cluster has twice as much network available. Our smaller cluster has two times 25 gig Ethernet adapters, so we had 50 gig worth of network bandwidth. Whereas the larger cluster, we had same network adapters, but 425 gig adapters, so we had twice the network bandwidth or 100 gig each. Storage side, we again double the storage on the larger cluster. So larger cluster had double the IOPS, and our utilization target for the testing was around 60% utilization, so that if we hit one node or if we take outage worth of one node, we have enough to accommodate on the other 2 nodes. So basically in a 3 node cluster, the max you can go is 66%. Okay, so what we did, we tested with one planned outage and one unplanned outage. So to test this, we built 3 node cluster, deploy VMs and containers, and we had kubed scheduler running on our clusters. Kubed scheduler is equivalent to VMware DRS. What it does, it balances the workload across all the nodes on the cluster. So we wanted to have similar functionality as VMware DRS offer. While cluster is in steady state, up and running, it should be balanced with the workload. Another thing was how to generate the load on these clusters. So what we did Ansible playbook with the Linux stress ng command, and that stress ng was running on the VMs and containers, and it was generating the enough CPU, memory, and disk IO load to bring the cluster to 60% utilization. Now we had two kind of outages that we planned: planned outages and unplanned outage. So planned outage was to drain the node gracefully and let the system migrate all the VMs to other node and see what is the recovery time. And in case of unplanned outage, basically we just pull the plug out of a server and see how long it took to recover the VMs and containers. Of course, we were running containers and VM side by side on these nodes. So here was our results. What we seen when we did the plan outage, our small cluster took 10 minutes and 15 seconds to recover 60 VMs and 30 containers. Whereas the large cluster, it took half of the time of just 5 minutes and 28 seconds to recover. And why the larger cluster took half of the time to recover? Reason: the larger cluster had more CPU cores, more memory, and more disk IOPS. Although disk IOPS was not a big deal, but greater network bandwidth, which was twice on the larger cluster, it really helped to live migrate the memory from the node that was down to the node that is up and running. And the faster CPU cores or higher CPU core count, it helped to schedule those workloads quickly on the desired node. So we learned that if your nodes are scaled properly or proportionally with the higher network bandwidth and better and more CPU cores, your planned recovery is much quicker. Second, we did unplanned recovery. In case of unplanned recovery, we simply pull the power plug out of one of our servers on each side, small cluster and the larger cluster. And what we learned that the recovery time was nearly identical. Although larger cluster took 40 odd seconds more to recover, but it had twice as much VMs and twice as much containers. So in case of unplanned recovery, what we noticed that faster CPU and higher disk IOPS really help to mitigate the boot storm, because when there's an unplanned recovery, there's no live memory migration. It's all about boot storm. So your VMs are booting and then your CPU need to schedule those VMs on where it can find the best suitable node. So in that case, we learned that higher CPU core count and your disk IOPS, better performing disk, really help to mitigate boot storm and power on these VMs and containers on the node. And the recovery time was, I mean, little different, 40 some second, but I still consider it's identical because we have recovered twice as much VMs and twice as much container. And that is another thing too that customer ask for: planned maintenance. So one of the concept is that in case of planned maintenance, if you have a larger node size, your planned maintenance would be much higher. But based on this lab testing, we are in a position to advise the customers, no, if your larger node size are scaled properly, then they does not necessarily increase your maintenance window. Instead, they cut your maintenance window by some degree. Okay, next slide. Why the larger cluster recovered faster? So as we discussed in the previous slide, the larger cluster has more network throughput. It had twice the network available, 100 gig versus 50 gig. So it can live migrate more VMs, push more memory when it was doing the live migrate. And then CPU helped to schedule those VMs in both cases, planned and unplanned migration. So based on that, we can simply conclude that blast radius is about recovery window, not the number of workload or VMs running on the node. So how to reduce blast radius in practice? So in our lab testing, we were using few OpenShift virtualization operators. One was, as I discussed earlier, VMware DRS equivalent, that was helping to balance the workloads on all 3 nodes when the cluster was up and running in the steady state. Kubed scheduler. Second, node health check operator. So what node health check operator does, it basically detect if there is a failure to the node and then report back to the other operators for any possible action. So then we have 2 kind of fencing agent: SNR, self node remediation agent, and FAR, fence agent remediation. The difference between these 2. So the combination of these 2 is equal to VMware HA. Many customers, they comes to us and ask about VMware DRS and VMware HA like features in OpenShift. So as we see, Kubed scheduler is VMware DRS equal feature, and SNR or FAR is pretty much comparable with VMware HA. The difference is SNR operator, it does work with operating system only. So it detects the node outage from the operating system, and then based on that, it start moving the VMs. So the default time is 5 minutes. After 5, or you can tune it down to maybe less than 5 minutes. I've seen as aggressive as 2 minutes. So OS reports the outage to SNR operator, and then node health check reports the outage to SNR, and then SNR operator take some actions. Second option for fencing agent is FAR or fence agent remediation. This is the most aggressive, and sometimes it's a better approach because it does not go by the OS. It directly work with your IPMI, ILO, IDRAC, or those kind of out-of-band management system. So that agent integrate with your out-of-band management system, detect if there's a network or node level outage, and based on those outages, it remediate. So benefit of using fence agent is basically you can have very aggressive timelines, pretty much comparable to VMware HA in matter of seconds. Whereas in SNR, you have little bit of, wiggle room in your outage window, and maybe eliminate some false positive as well. Or you can use combination of both, not rely on just one. Second, rebalance we already discussed. So Kubed scheduler, you can have ton load of tuning that you can do on the Kubed scheduler, how many live migrations you want to perform, and how you want to spread your workload between your nodes. So key lessons or summary: yes, bigger node does increase scope of the impact, but not necessarily the impact window. Planned maintenance can be faster if, as long as you scale your node proportionally and properly. Network bandwidth, disk IOPS, and CPU faster and more CPU is the key here. And in order to recover timely, the key is fast detection with node health check, SNR, and FAR, plus remediation, migrate or start your VMs on a new node, and after that, rebalancing your workloads when your failure is remediated or your node is back online. And the combination of all 3 reduce your blast radius and impact window. So thank you very much, guys. This was my presentation. I want to do a live demo, but the cluster hardware we have, another sister team is doing some critical AI work. So I could not show that live demo, maybe in one of our next calls. And if there is any question, please feel free to bring up in the chat and I'll be happy to answer those.
Awesome. Otto, we did get one question, and I'm going to stop sharing for you really quick. Okay. We got one question, and this might be just a general question for the panel here, but it's from Michael Stefani 7513. Are you seeing VM-based OpenShift clusters running on top of bare metal OpenShift clusters gaining adoption? Running VM-based OpenShift on other platforms is a double whammy on licensing costs.
I can probably take that one, Jonny. Probably you can add to it. Yeah. Short answer is absolutely yes. We are seeing a lot of traction where we are seeing our customers move to bare metal for exactly the same reason. Plus, also they are tying it to their hardware refresh life cycles, LCM events, etc. In addition, what we are also seeing is a lot of uptake on our managed services on the hyperscalers, whether it's ROSA on AWS or ARO on Azure, where we do provide virtualization on bare metal on the hyperscaler as a native option in OpenShift, managed OpenShift. So that makes a lot of sense from both a cost of operations perspective. Both your capex and opex obviously get reduced significantly, especially the licensing piece. But also, if you think about it, as Jonathan introduced earlier in the beginning, OpenShift is the one platform to run all your workloads. So as we are seeing VM migrations, we are also seeing a concurrent modernization effort moving towards containers. And of course, AI is the buzzword right now. In fact, we will be demoing something that's based on ML in a minute. So having all your workloads in a managed, controlled environment, which has the same management surface, has the cost efficiencies for licensing, as well as the performance that you get from bare metal, makes an absolute sense. And we are seeing the trend definitely moving towards that. So I'm not sure if it answered your question, Michael, but if you want to follow through, definitely post it on the chat.
Yeah, definitely. For sure, Michael, if you have follow-on questions, put them here. If you don't want to ask here, feel free to shoot me an email, and we'll make sure that we get a good answer for you. Awesome. So with that, then Anupam, I guess, do you want to kick it off? And great job, Atta. It was a great presentation. So thank you for that.
Absolutely.
And
sure.
before, I'm sorry, I did that. I set you up, and then I have to talk more. I'm sorry, I didn't mean to do that. I did want to say we did an episode on the node health check operator. I don't remember when. It was episode 159. I pasted the link in the chat. If you want to check it out, Andrew did a deep dive of the node health check and the SNRs and the FAR and stuff like that. So it was right after I think it went GA. So yeah, if you're interested, check it out. And if you have questions about it, feel free again to reach out to us. All right, Anupam, I'm sorry about that. Here you go.
Not a problem, Jonny. That was important. So let's move to the next topic for today's session. What we want to talk about is essentially a follow-through of last week's session, which Atta, I believe, Mache, and Jared presented on essentially the core foundations of OpenShift virtualization. So you would have seen a demo of the platform itself, plus a migration that we did live on the session. I believe there were some demo gods not being very happy that day, but that's demos. But anyway, one of the key points there was that while the technology is one piece of it, planning is essential. In fact, what Atta described earlier on in terms of the recovery planning that we need, planning definitely becomes a big portion of that. And once you start looking at VM estates that you want to migrate to OpenShift that have a critical mass, we are easily seeing thousands of VMs. Some of them are approaching hundreds of thousands of VMs. So obviously there are very large estates that need to be migrated. So a forward planning is absolutely essential because we are talking about multi-year wave-based staged migration events that need to happen. So as part of that, one of the key questions that we often hear is how long would the migration take? Which VMs are candidates for the migration? What are the preconditions that are required for the migration to even begin, or any preconditioning of the VMs or remediation of the VM workloads or the operating systems or their overall characterization in terms of resource allocations? What are the things that we need to plan for? What are the things we need to work on before we start the migration? And how do we create a roadmap and a realistic timeline for the migration that considers all these dependencies with all the milestones determined for what changes are required, and therefore the execution plan gets built? It's a fantastic question because obviously we're dealing with large-scale assets. We are dealing with situations where you need to have zero downtime. We are dealing with additional unrelated pressures of resource constraints, hardware constraints. We are in the middle of a massive RAM and flash shortage in terms of supply chain. So planning becomes even more important there. So from that perspective, what we have been working on, and especially Jon and I and our larger team that's not here today, is that over the last couple of years, we have built a traditional ML-based number crunching mechanism, which looks at your existing VM assets and inventory, analyzes that based on our experience as well as what we know about our own platform. So therefore, all those heuristics are built in. And it then generates a realistic plan which shows you both the complexity of the migration, categorizes them in order. It identifies areas where you need to focus, the preconditions that I spoke about before, as well as it gives you a roadmap that you can then translate into a proper project plan. For anyone who is a fan of Gantt charts, we can actually generate those as well, and gives you both the roadmap as well as the change events that are required. Now, this is, again, as I said, traditional ML. I know with LLMs, AI, it often gets equated to LLMs, but AI, the space of AI is bigger than that. We do have ideas around potentially integrating LLMs later on, but what we are going to show today is traditional ML. We're running it on Jupyter notebooks using the standard Python data sciences toolkits, whether it be Pandas, NumPy, SkyPy, and all the ecosystem that comes around it. Now, before you turn off the stream and say that I don't want to ever see a Jupyter notebook because it's too tough, just stay with us for a while, because what we have also built, especially Jon has built over the last month or so, is a fantastic front end which isolates and abstracts all the garnly craziness that is happening behind that. So with that said, Jon, this is the point where I would probably transition to you, because I think screen sharing and demo time is in order. Okay, just one point before I forget. I forgot to mention this. Now, I did mention that, yeah, demos, right? We do need some input, obviously, into this tool, right? So what we are basing the analysis on is a live, in this case, we'll obviously use static files, but we prefer using RV tools-based extracts and inventories of your existing VMware assets. So anyone who runs a VMware cluster of any size, you're probably familiar with RV tools. It is a very well-known third-party tool. It's completely free that you can download and run. You're probably already running it because it works much better than the traditional VMware tooling for inventory, especially dynamic inventory. So before we switch to Jon, Jonny, if you could just quickly show the download URL, because there are quite a few versions of RV tools that's floating on the internet. The homepage for RV tools is robware.net, but unfortunately, it has had some issues in the past. So this is the link we recommend that you download it from. It has a checksum also that you can validate the download against. So Jonny, if you could just bring up that URL for a sec, or post it. I think you posted it. Thank you.
I did post it. Yep.
Perfect. So it's from Dell. Make sure when you download it, use the checksum to ensure that you have the right binary. It is a Windows binary, so that's the host you run it on. And now, Jon, over to you.
You're muted, Jon. Do you want me to share your screen?
Yeah, there we go. Still having a little challenges with internet speed here. Anyway, this is this tool, as Anupam said, I built the front end, basically turned the Jupyter notebooks into a Jupyter server. So I've got a VM, and we're running a Jupyter notebook server on the back end, and a bunch of other components to get us the displays and have it look, like we want. The analyzing tool, when you first log in, it'll give you your home page here, and kind of gives a high level of what you're going to see on the next page. And then down below, I've got some ancillary scripts that I've written over time to look at certain data points in those files, or even files from Rev that we've had some customers ask for, and it takes the output of Rev and formats it into a RV tools type of format so that we can process it the same way we would process anything else. So we go to the input page, and we go through, we load up files, everything's drop in, supply customer name, pick the chart types that you want. This is the vMotion per host. Essentially, VMware has a default cap of 8 VMs per host can move. So we've got that in there. The number of work streams. in our handling, there's a little help that I've got that'll tell you everything, what everything is. And we've got, what times you want to do it, code freeze times where you're not going to be reprovisioning or migrating VMs. And one of the most important pieces is the network section. There's been a lot of tools as we've gone through the journey, and it's always, how long is it going to take to get a VM from point A to point B? And it's more than just the one VM, it's all VMs. So, I've created this section and I'm still doing some work on it, but to look at it holistically and, how many VMs can we actually move at one time and what's that going to look like? And we have some parameters in here that we can set. How many nodes are we talking about? The type of load balancing, LACP and balanced SLB, those are the same, but I just put it in there for completeness. And then, if you're doing active backup, you're only going to use one adapter. And with this, I've I've got some explanations as to why. And then for more information, I've went and I created a page that has a speed calculator in it. And then as we go down, it explains everything that I've implemented, basically the math behind what I'm doing. And I've provided links to all the places where I got information to build this page. And so this is all based on what you should have, what the average is for, how much noise you got on your network for network efficiency. And we've, got all this light read for network geeks. But it was something that I was getting a lot of questions on. And as you explain it, it's hard to not go down very deep technical rabbit holes. So I provided this so that it provides something that somebody can self-educate on and learn. So when we get back here, we got a helpers file section, and this should actually be called filters, because what these do are put the bounds on what we're going to see in the outputs. When we get the VMA, customers will usually have a group of VMs that they're like, yeah, these ones here, they're just going to go away. We're going to make them disappear during the migration. And then sometimes it's like, we don't want to look at a particular customer or cluster at this point in time. We'll look at it later. And then we've got our supported or what is not supported for OSs. So I've got a list of OSs here that aren't supported, and to go ahead and filter out of our reports. And then we've got a redeploy pattern, because we do have customers that have VMs that they're like, we'll just kill them and then just spin up new ones, because we've got all the automation in place to go ahead and rebuild specific type of machines in a short period of time. And that goes back to your what we have, which is post-migration time. How much time is it going to take to get those VMs up? How much is, after the VM is actually up, how long is it going to take to make it usable? So we've got a variable here so that when you look at what's migration going to take, because the migration is more than just getting a bit from point A to point B, you have to have a usable machine at the end. Mm-hmm. And then we've got the migrations. So this would be the ones that are going to be using the MTV, moving from point A to point B. And we call out databases because those, at times, depending on the database type, it will require special handling. And then we've got here things just to ignore, and it's a lot of the VMware components. And then I've got an environments mapping file so that if somebody, because everybody's, if they have the environment field populated from the from a VMware perspective, then we can filter on those, and it's, does it prod, production, PRD, and these are all files that can be edited. These allow direct input, and it's just standard regex. And to see what the files look like, this is our environment mapping file. It's just simple JSON. So you can add, delete based on what you want to see. And then you can see for our filter files, it's just standard regex type of file. So we can drag and drop them, put them in there, and then we would kick off an analysis. So what I'm going to do is, as soon as I find my thing, I'm going to go ahead and run one. I'll make it a small one because it does take time to run. And so we'll go ahead and kick this one off.
So just a quick question, Jan. I'm sorry to talk over you there. Is this is something that it doesn't replace MTV or anything like that, right? This is like a complementary tool to MTV. So then,
correct.
How do you use these two together? Do you take the output from this tool and then can you apply it to MTV to where it can then like start the migration based off of the list of VMs that get populated? Or yeah, I'm just trying to figure out like how it all works together.
So this tool creates the information that provides a report back to the customer to say, this is how long it's going to take you to do your migration.
Okay.
And so we've got here, so the top level is to, how long is it going to take us to do a migration? So this will have all the things and broke down by environment. How many VMs are we talking about? Are they redeploy or migration? And distribution by environments. How many VMs do you have in development that are tag development? How many do you have that you have no idea if it's prod or dev or a sandbox? I mean, as a VMware admin, you may know where those are, but there's nothing that's defining it from the VM perspective as to where it lives. There are some customers that'll have vCenters or clusters that are called out to be in particular, whether it's development, prod, sandbox, and then there's others that it's a mixed environment and it's just the VMs, and a single, vCenter or cluster can have multiple environments that are attached to it. So if we have those defined in the environments field in the VMs, then we can get a better breakdown of where we're at.
And one more thing before you jump off, I'm sorry. So I see that you have redeploy and migrate there. Like, why would you redeploy over migrate? What's the decision point there?
It's so the current customer I'm working for, they have a bunch of VMs that are just cookie cutter.
Mm-hmm.
They've got thousands of VMs, and it's all the same, and they already have a pipeline that builds it. They originally just had it as a kickstart. It builds it and then connects to their automation, and the server gets built. So things like that, where you already have a pipeline for something like that in place, and it makes sense. If the data that's on those machines is ephemeral, then those are the kind of machines that you would be, okay, let's go ahead and just rebuild those. It's going to be quicker than doing a migration, because the data that's on it is being pulled from somewhere else.
Okay. So that's the cattle part of it. That's the...
Yes, very much.
One part of it. And Jonny, another set of criteria which we also see customers using for redeploy versus migrate is when you have, let's say, a modernization opportunity. You have to upgrade your OS, you have to rebuild the VM anyway, right? So in those scenarios, it makes much more sense to just create the new VM and host the new VM via redeploy rather than again going through the whole cycle. Another
Gotcha.
big category of VMs is third-party appliances, right? So you have the blob
Mhm.
essentially of the VM image, and you might as well just redeploy it rather than going through again the same process of going to VMware, deploying it on a vSphere, then migrating it. It doesn't simply make sense. Also, finally, tying back to what Jon said in the beginning, for customers who have a strong established pipeline for managing the entire VM lifecycle, they probably have a template that they use to clone and create the base VM, add all the workload stacks on top of it, create a new image. Pointing the pipeline to OpenShift is usually much faster in terms of the duration required to establish a new VM on the OpenShift platform as opposed to going through the chain. So it's a mix and match. Often you'll see situations where you will not have completely 100% of one or the other. You'll have a mix of redeploy and migration.
Okay, awesome. Thank you.
Yeah. So with that said, we'll go ahead and I'm going to kick this off while I go through the reports. So the tool, we've got a section here where it gives us all the reports that have been run. We can do a compare. So if we go and we make changes, let's say we come back and the customer goes, okay, well, let's look at, other options that we can have. And then we can select this and do a compare. And that'll come up and it'll tell us what's different. So we can see, okay, our total VMs changed based on, we're going to add these other machines into the mix. Well, how much space does that change it? So this gives us a delta between two different reports.
Oh, very nice.
And then our report, we got all these sections and we can move them around so that if I'm going to show customer, hey, this is what we're looking at before I export something, I put all the important stuff that we're going to look at the top. And when we come down and we look, we got the estimated times, and this gets, drills down. To where we can, gather specific information about the different aspects of the migration. So we get a lot of information.
Yeah, that is awesome.
And we've got, the environment breakdowns, and then other things that we've got is an index of where we've got a mismatch. And I'm not saying any, I've run into an issue where we had some mismatches in the files for what the index is versus what a VM or vCenter says, and it just calls it out so that you can go and look at it. And then we look at our top 10 distributions of operating systems. So if they go, what's the majority of our environment that we're going to migrate? And where that becomes really important is especially with things around Windows that you're going to have, and if they're databases, it's going to call it out so that you can say, okay, we've got a greater percentage of these, so we're going to have to make sure we plan accordingly. And then we have the grand total summary. This is how long it's going to take to do everything. And then I've got the work stream breaks down essentially by environment. And then we've got the, just execution. This is what it's going to look like. If we only run one migration path, or if we're running multiple. So if we have multiple OpenShift clusters that we're migrating to, and we're going to pull from multiple different vCenters, then or clusters, then we increase this, and it'll change it, and it'll give us, a delta in how the difference is going to be. And then one of the other aspects is I've had a client that had old SAN, and the issue is it can only handle so many connections per host. So I added this in so we can see how many connections are coming from each cluster, and then it breaks it down how many are coming from each of the hypervisors, for each cluster in the hypervisor, so that we can look at this and ensure that we're not going to overrun older storage if the client is trying to reuse storage. So I put this in here. We don't run into that a lot, but it's one of those ran into it once. It sounded like a good idea, so I added it to the tool. And then we have our breakdowns, vCenter breakdowns, how many VMs, how many hosts do they have, how many disks. And, then we go, how much data are we actually going to move? And this will break it down by operating systems. And then we've got our disk sizes, large, medium, small, extra large. This just kind of gives it, because this is going to where your time is going to be taking to migrate these. The one aspect that I have not yet added, and that's where a SAN on the back end can do the migration of data for you. That's a new feature that came out during the development of this tool, and I don't have, personal experience with it, and I need some more information to be able to build that in to the logic and make that an option to say, oh, we got a SAN that can help us with the migrations. You just migrate the VM, and we'll migrate all the the shell essentially, and we'll migrate all the data on the back end. So as that becomes more of a accepted feature in the SANs, I'll add that into this so that we can add it to the to the example. And then I've got a what does our full scope look like? And because it's large, it'll tell you, hey, this is going to take a moment, so you can click on it. And then this is like the full inventory that's not in scope, and it tells us why it's not in scope. The full inventory is essentially everything that we said is in scope. This is everything that we either filtered out, or the logic had said, you're not part of the migration for a reason. So we can go use this and then go back to the customer and go, okay, well, what about these machines? Oh, those are going to be appliances. Okay, let's add them in, and we'll just add them in so that they require special handling, so that we can get a better idea. And then I've got all the eye candy charts for all the data that we have above.
Yes, well, it's important.
Yep. And then, so you can export the report to an HTML. Now, where this becomes useful is this is what's used to give the report back to the client. We pull it out and give it to the client. And one of the things that we're looking at doing is when we have the export, it'll export into an LLM. And that's one of the parts that Anupam is working on, so that this data will go directly into a rendering of a report. Now, you brought up the can we use the data here and then create migration migration plans and things from this. I've thought about being able to have that data, because the data's here. The only issue with that is what are we really going to migrate and from where to where? We're missing where's the endpoint going to live? But we could, and I can add that feature to be able to dump the data that we can then re-ingest into a tool like Ansible or something of that nature, to be able to create migration plans for us.
Yeah, I'm just thinking, like, you look at the amount of information that you're getting from this, and it seems like you would be able to point it at, use it as like a source for your your source VMs that you want to move from like whatever cluster, and then you could just define or whatever, right? Some other type of automation to I think it's awesome, man. Just the amount of info that you get from this is crazy.
Yeah. And one of the reasons when I was working on the migration factory team, one of the things was to build a inventory file based on what it finds in the cluster. So an Ansible job would go out and grab all that information up front. And that's probably why I was like, do I need to put that in here? Nah, we've got that covered. But that's only looking at one aspect. So I definitely could add that in as another report option for download, for putting out. When we go to do our
section,
report, go ahead.
What I was saying is basically another section in the report. What I wanted to just chip in very quickly here is, as you can probably tell from what Jan just described, both in terms of what we have and what we want to build, there's a long roadmap of features that our backlog is getting bigger. Let's just put it that way. But just to tie it back to what you're seeing today, especially for our audience on the stream, what you have as of today immediately is a tool that Red Hat Consulting can provide. So definitely talk to your Red Hat account rep. We usually do what is called a VM migration analysis, or VMA for short, where apart from a lot of other things in terms of understanding your environment, understanding your local constraints and possibilities, we also look at your inventory using this tool and a few other things to give you a very detailed analysis and report of the feasibility of the migration, the scope and scale of the migration, the complexity, as well as obviously the timelines that I spoke about, which is an extremely important part of the planning that I spoke about earlier, because those are the foundational blocks essentially. So this is something that we have been building, and obviously you'll see a lot of it as you engage with Red Hat going forward. We are essentially trying to make the migration as easy as possible and as controlled and managed as possible for you. And this tool is a part of that overall toolkit that we bring to the table. MTV that Jonny was referring to is obviously the execution part of it that does the implementation, which again, you would have seen a demo in last week's session. Now, one question here would be, how do I get access to this? I'm pretty sure even if the question may not have come, I'll answer this right away. A simpler version of this tool is already available for you on your Red Hat console as of today, right now. So, Jonny, if you could post the link, and maybe I'll quickly share the screen just so that people can see what this looks like.
I've got it.
Perfect. So this is the tool that if you log in with, you do need to log into your console, Red Hat console. And once you go there, we will post the link, obviously, so you can go directly there. This is a simplified version of the same thing, where you upload your VMware assets. You essentially upload the VMware RV Tools inventory report, and it then runs a simpler version of this analysis and then generates a report for you. And I think there you go. So I think Jan had already preloaded a report for you to see. So this will give you a view as to what is migratable, what is the complexity. It will all hit upon all the key elements of migration, disk size, network, some of the OS complexities that come along in terms of legacy and supportable and unsupportable aspects. So definitely go test this out. This is free. You just need to log in and you need the RV Tools extract. And once you have that, as you can see, you can then go through individual recommendations that the tool provides in terms of migration preparedness. So this is really the call to action if there was any for this one. But for the larger tool, this is an awesome tool, Jonny, because this is completely self-service. It immediately gets you a frame of how big of a migration event are you really going to, foresee or plan for.
Yeah, that is awesome. So let me ask you, if you generate this report, right, and you're using this and you're getting ready to do your migration plan and stuff like that, is this something that you can provide back to support and say, hey, I started, here's what it said I was going to do. I started my migration. Here's what the result was. And then but there's a delta, maybe not all the VMs migrated or whatever, right? Is this part of the package that you would give back to support? And then they would say, oh,
it's
yeah, you know what?
Of the debug. Yeah, it's definitely one piece of the debug toolkit that the support team can use. So it's not the only thing, but it definitely helps because it's based on actual live data that we inventoried and discovered. So it's as close as possible to reality. So definitely helps. Not only for that, it also helps our customers because whoever is doing the migration can, with this tool especially, look at the before and after, like Jan was displaying earlier. So you can always keep doing a diff and at least at major migration wave checkpoints or milestones. You can see the percentage of difference that is happening in terms of how much has been migrated. But more importantly, how has your risk and complexity profile changed? Because let's be real, environments keep changing, right? So if I do take a snapshot today, it may not be true 12 months from now. So this will give you that kind of a perspective, if you will.
Yeah, and there's another tool that's in the works from some other individuals that is essentially RV tools for OpenShift. So it gives you a view of what you already have, on your OpenShift virtualization environment. So it'll interrogate that and it'll give you a similar report to what this will do, and then now you can see your deltas between the two, post, pre-migration, post-migration.
Yeah. Oh, that's dope. You know what would be cool, and this is just me being a nerd right now, is like if you had like a Grafana dashboard or a Percy's dashboard or something like that, where you could inject that data, right? I ran this tool. Hey, here's my JSON. I dump that into a config map or something like that, mounts it in, and it reads it, and it's like, hey, here's before, and then you can do that comparison within your OpenShift cluster. That'd be kind of dope. Just from a nerd.
That's an
I'm
awesome
sorry.
idea. That's an awesome idea.
Yeah, and I've actually thought about making an import for this tool so it can go. You can do it from either side, essentially. Once we get this tool out of its alpha stage, then we'll have things on it. I've done a lot of things around security and user isolation and encrypting all the data at rest and isolating memory space and everything, so that we can have multiple users doing this all at the same time, and we don't have to worry about cross-contamination of customer data. And the one thing that my tool,
just to be clear, because Jan, since you mentioned that, just to make sure our audience understands it, there is no cross-contamination happening today either. So just to put it at rest.
Sure.
Yeah. So the one other feature I've got is if you log out, it'll wipe out your data on there. So, and that was more of a security function that we may change, but I have to work with security on what can I do with this tool, and what are we allowed to have and not have. So it's still in its alpha phase, so I'm just working on the assumption of be as secure as possible.
Yeah, absolutely. And I think one thing I really liked early on was like, you're giving a ton of information, right? Like it's if you're a nerd, you're like, oh yeah, I'd love this, right? But if you're not, it's a complete snooze fest. So, but having the ability to like scope it down to here's what you said is important to you. Bam, here you go. And then here's the Cliff Notes version of it. And then here's the formulas. Here's how we got to this, right? So that way it's not just Jonny and Red Hat Consulting saying, yeah, you need X. Here's the data that backs it all up. I think that's awesome. That I would not have even thought to do that, to be honest. Like that's super thoughtful, and yeah, I love it. That's awesome.
Probably live need actually, Jonny, because end of the day, to your point, Jan, if I could, the executive summary selection that you see there, this actually came from exactly the same need that you just described, where I need progressive disclosure of details, because otherwise it generates a lot of things. Again, for a nerd, it's like a playground, but for a planning exercise, you need progressive disclosure. So the executive summary profile, in fact, I had suggested this feature to Jan to build, where we can start with a small, high-level, high-impact view of what really does this analysis mean for, let's say, an executive team or a planning team. And then as we go down the implementation details, you can select different things and address that particular stakeholder community separately.
Yeah.
So it's the same tool, but
Yeah.
it addresses different audiences.
No, it's awesome. And like my memory from this is I had a manager named Jack, and this is 100 years ago, and we were doing a migration right from one data center to another. This was way before Red Hat, and he got so pissed at me because I'm trying to explain why I was doing this, right? So I was providing all the math and stuff like that, and he's like, "Dude, I don't care." He's like, "Just tell me what I need to know so I can make a decision." And that's where like all this that's like the whole basis for everything I do now. I was like, okay, do you actually care about this, or do you want to be bored to death, or do you just want the cliff notes? Sorry, Jan, I know you're trying to say something. I keep talking, so
Please go ahead.
No. So a couple of things was, we've got some canned report selections, or you can select your own and do it that way. And there's other features. We have the information for, well, what's my hypervisor? What model is it running on? What piece of bare metal is it? And how's that going to impact my environment by is it even supported hardware anymore? Because we've got a lot of customers that want to reuse what they have. So, part of this tool will actually allow you to look at that and say, okay, well, we can X amount of our existing inventory once we get VMs moved off of it. So it'll provide that information as well.
Yeah, that's really cool, man. That's really cool. Yeah, this
built. I was just gonna say it's built based on information and myself getting the information of actually doing the assessments, and I think that's why we've got a lot of the granularity in here. Is the other architects that I work with, have asked, well, can you do this with a report? Can you add this to a report? And that's kind of how this all got built, with all the other functionality that we've got here, is taking real input from the field and trying to get it turned around as quick as possible to be usable.
Yeah. Right. Yeah, that's awesome. All right, so I'm gonna kick over. We have a question from the audience, and it's been a long time coming. So, Cybug, I apologize for taking so long. I just wanted to make sure that Jan got through the demo, because there's a lot of information, a lot of things to cover, and a lot of good things. So the question from Cybug is, can you talk about OpenShift cluster upgrades, how we can safely go from 4.18 to the latest version? And the safest thing, the easiest way to do this is there's a tool that's online. It's free for you to use. But you do have to have a Red Hat account. Now, with that being said, you don't have to have don't think of that as you have to have a Red Hat subscription to something crazy or anything like that. You can use your developer subscription, like the tool that these guys were pointing to in the console. You should be able to get to that through your developer subscription. So if you have a developer sub, you should be able to access these tools. Now, the first thing that I will point to is, I'm just going to share my screen here. Maybe.
I can bring it up. Yeah, Jonny.
I got it right here. Yep.
Perfect.
Okay. So I'm going to share the link really quick. All right, but go to this tool. The first thing you'll see is you have an update path. And what you can do is you can say, hey, my current channel, let's just call it, you said you're on 418. So we'll say stable 418. We want to, my current OpenShift is going to be, I want to type, but I'm afraid of losing my focus. So 418, want to go to the latest 421. So 4.21.8. This will do is this will generate an upgrade path. So what this is saying is if you're on 4.18.1 right now, you have to update to 4.18.35. All right. Once you get to 4.18.35, then you'll need to upgrade to 4.19.26. And then from there to 4.20.17, and then from there to 4.21.8. That's the safest path on the stable channel to get to the latest release of OpenShift. If you are a glutton for punishment and you want to see it in a graph, you can select your channel, and then you can kind of see like just all the bananas things that are out there. It's a pretty cool graph, but for me, I like the individual map that much better. But obviously, if you clear the screen, it goes away because that's fun. Can I just type in here? Yes. All right, and so then we'll go back to 4.21.8. But yeah, if there was a difference, like if you could go from like 420 to 4, like this is a good example. If you're already on 4.20.17, or if you're already on 4.20, you would have to update to 4.20.17, and then you could jump to 4.21.8. And all this is actually in your, if you look in the console of your cluster, when you're doing your upgrade, once you change the channel, it'll tell you the channel that you can go to. Now, if you're doing this disconnected, it's a little more intense because you have to download, you have to mirror the specific container images for your cluster. And then you'll have to update the Cincinnati operator and the update graph and all that stuff within your Cincinnati operator to do the deployment. That's actually probably a good topic for a live stream, is to do a disconnected upgrade. But yeah, so that's the rub. If you like, again, you can use your developer subscription for this and for the console thing. And yeah, the upgrades, it generally, if you're going from one version to another and there's an upgrade or an API that's being removed that could potentially cause issues, it'll be blocked in the upgrade scenario, and then you'll have to go in and you'll have to patch your system to accept that you're willing to take the risk. So instead of it just blindly applying the upgrade and killing your cluster, it wants you to go in and make sure that you're sure that you want to update and upgrade. So that's the rub. I think that this is probably a good. This is a definite, live stream worthy type of topic. So Anupam, I don't know if you want to add anything, or Jan.
No, I think you covered it, Jonny. This, unfortunately, because 418 is currently on EUS, and there have been at least 3 major versions since then. This is the recommended path. This is also the safest path. I think I should stress on the safe part of it. Now, do you need to necessarily, wait for another 6 months before you go through each of the steps? You do not. We can build automation which can step you through all those versions, validate at each step, and still get you to the target state. It's just that you cannot jump from 418 to 421 today, at least not safely. And then that's why you need to follow this path. But it's doable. The other thing is it's definitely doable. A lot of customers are on 418 or even older versions in some cases, and we do help them get to the latest, whichever version they choose. Because many customers do N-1, so we can certainly support that as well.
Yep, awesome. All right, well, there's no more questions. If Anupam and Jan, if you have any last closing remarks, if you want to go ahead and make them now while I try and figure out where all these buttons are that I need to press.
Just one last call to action. Again, do test out the console version that we had shared earlier. That's you just need a login and go try it out. None of your data is stored on our system, so be assured that it's completely your own report and an isolated report. The other thing is planning is important. The technology bits are really cool, gets all of the nerds excited, but planning is what makes a successful migration happen. So therefore, if you think this is of interest to you, definitely talk to your Red Hat representative, account rep, or anyone else you're working with Red Hat from. And we can certainly talk about doing an assessment for you where, again, this tool and a lot of other things that come along with it, we can deploy it to get you a feasible, well-structured, detailed plan of how can you move to OpenShift work.
Yeah, awesome. Jan, you got anything you want to go away with, or are you good to go?
I'm good to go. I've spent a lot of weekends and nights working on this. It's not my day job.
Yeah. No, it looks good, man. And like I said, I've done this world a long time ago, back before we had cool tools like this. And just knowing what like leadership is looking for, and knowing what we can provide, and then fast forwarding to today, where now we've got tech that can do this, and actually a nice report where we can structure it. And I think it's outstanding. Great job.
Thank you.
All right, awesome. So with that, we're going to go ahead and close out. Anupam, thank you very much. Jan, seriously, I know it's never easy coming on these things and putting yourself out there and doing demos and stuff like that, but really appreciate your time and really appreciate the effort. Jonathan and Atta had to drop, so thank you to them. And Jonathan, thank you for putting all this together. I really do appreciate it, man. So it means a lot. Thank you. With that said, Again, next couple weeks, we're trying to figure out what we're going to talk about. And then on the 29th, we're going to have the UX team come back and talk about ACS. So cool. Until then, everybody have a good one.
Bye, everyone.